For centuries, we saw the moon as a beautiful, barren world, gray dust, silent craters, and no water in sight. The Apollo astronauts brought back rocks that seemed to confirm this, dry as a bone. So the moon was written off as a waterless desert. But science thrives on surprises, and the moon had a big one. It has water. Not oceans or lakes, but water molecules hidden in the soil and ice locked in its darkest shadows. This discovery flipped our understanding of the moon, and the solar system, on its head. Suddenly the moon wasn't just a monument to history, but a potential outpost for our future. Imagine finding a secret pantry in a house you thought you knew inside and out. That's what this felt like for scientists. The moon's hidden water means its story, and ours, needs a rewrite. Now the moon is more than a dusty relic. It's a stepping stone for space exploration. Water on the moon challenges our everyday ideas. Here it's not puddles or rain, but molecules clinging to dust and ancient ice in eternal shadow. Understanding this water is like solving a cosmic mystery, with clues that reshape how we see planets and the potential for life. The moon's water is a game changer, making it a vital part of our journey to the stars. It's a reminder, the universe is always more surprising than we expect. And sometimes, the biggest discoveries are hiding right next door. So, how did we find this water? Not with a shovel, but with robotic detectives, spacecraft with powerful instruments. India's Chandrayaan-1 orbited the moon in 2008, carrying NASA's Moon Mineralogy Mapper, or M3. M3 wasn't a regular camera, it was a spectrometer, revealing what the surface is made of by how it reflects light. Water and hydroxyl molecules have a unique fingerprint in infrared light. When scientists checked the data, they saw this fingerprint almost everywhere on the moon. Another instrument, Mini-RF, used radar to peer into the moon's polar craters, places untouched by sunlight for billions of years. The radar signals matched what you'd expect from thick ice deposits. Then, in 2020, NASA's SOFIA Observatory confirmed water signals even on sunlit surfaces. This proved the water was real and widespread, not just a fluke or error. Thanks to these missions, we now know the moon isn't bone dry but holds a hidden reservoir of water. It's a triumph of technology and curiosity, and it's only the beginning of what we'll discover. When we say there's water on the moon, it's not in streams or ponds. The moon's harsh environment means liquid water can't survive. It either boils away or freezes solid. Instead, water exists as molecules mixed into the lunar soil or regolith, and as ice in the coldest craters. Some of this water forms when hydrogen from the solar wind hits oxygen in the soil, creating water and hydroxyl molecules. It's like the moon is slowly making its own water, molecule by molecule. The real treasure, though, is ice at the poles, trapped in craters that never see sunlight, at temperatures colder than anywhere else in the solar system. This ice could be ancient, delivered by comets or asteroids billions of years ago. The water molecules in the soil are sparse, far drier than Earth's deserts, but over the whole moon it adds up. The polar ice could be much more concentrated, forming a kind of lunar permafrost. Finding and using these two types of water will take different strategies, but both are crucial for future exploration. The moon's water is a resource waiting to be unlocked. Water on the moon isn't just a scientific curiosity, it's a game changer for space exploration. Shipping water from Earth is expensive, but using what's already on the moon, called in situ resource utilization, makes long-term missions possible. Astronauts could drink it, rehydrate food, and use it for sanitation. But water is more than just for drinking. Split into hydrogen and oxygen, it becomes air to breathe and rocket fuel to launch deeper into space. Imagine the moon as a cosmic refueling station, making missions to Mars cheaper and easier. To get water from the soil, we could use rovers to scoop up regolith and heat it, releasing water as steam to be collected. For polar ice, we'd need mining robots that can work in extreme cold and darkness, drilling and heating the icy ground. It's a huge engineering challenge, but the payoff is enormous. The moon could become a gateway to the solar system. Local water means safer, longer missions, and a future where we live and work beyond Earth. The moon's hidden water could fuel humanity's next giant leap, and it all starts with unlocking what's already there. Mapping the moon's water reveals it's not spread evenly. Some places are wetter, some drier. Young volcanic plains are especially dry, likely because eruptions boiled away any water in the soil. But impact craters tell a different story. When meteoroids smash into the moon, they dig up material from deep below, often richer in water. This hints at a wetter layer hidden beneath the surface, protected from the harsh environment. These findings challenge the old idea that the moon was always bone dry after its violent birth. Maybe it held on to some original water, or maybe comets and asteroids delivered it later. The moon's surface is a patchwork of dry volcanic zones and wetter impact sites, a geological map of its history. The real surprise? There could be much more water underground than we see on the surface. Water isn't just a surface dusting, it might be a fundamental part of the moon's geology, and that changes everything about how we see our closest neighbor. The moon's water story stretches far beyond our solar system. Water is one of the most common molecules in the universe, found even around distant stars like V883 Orionis. There, astronomers have detected vast clouds of water vapor in the disks where planets and moons are born. Water forms naturally in these stellar nurseries, freezing onto dust grains that eventually build planets, moons, and comets. This means our solar system, and the moon, started out rich in water. The ice we find on the moon today could be an ancient inheritance delivered by comets or trapped during its formation. The water in your glass, the ice at the moon's poles, and vapor around distant stars all share a cosmic origin. Water is a traveler, moving from interstellar clouds to new worlds. The moon's water isn't an anomaly, it's part of a universal story. Our solar system was born wet, and the moon has held onto its share for billions of years. It's a reminder that we're all connected by the same cosmic ingredients. So, what does all this mean? The moon's water is more than a curiosity, it's a revelation. It shows that water is common, tough, and persistent even in harsh places. If the moon can hold on to water, so can countless other worlds. This boosts our hopes for finding life elsewhere. Water is the key ingredient, and now we know it's everywhere. The moon's water is a signpost, pointing to a universe full of potential habitats. It makes the search for life on Mars or the icy moons of Jupiter and Saturn even more promising. The moon's gray dust has revealed a vibrant truth. Earth isn't an isolated oasis, but part of a vast, interconnected system. The water on the moon links us to our origins and lights the way for our future. It inspires us to keep exploring, keep questioning, and keep dreaming. Because if the moon can surprise us, imagine what else the universe is hiding.